Good morning, students. When we purchase any electrical appliance, we inquire about its wattage from the shopkeeper. Now, in the figure which is given in the slide, we are seeing different types of electrical gadgets like vacuum cleaner, hair dryer, electric stove, and every case in the table, safe wattage is given. Now, what was the name of a scientist, and from that the word watt came, WATT. It is the SI unit of a new physical quantity which we will be going to learn today. As we discussed earlier, that power of a device is measured by the unit watt. Now, how can we define power? What is power? Power is defined as the rate of doing work. Rate means per unit time. So, power will be is equal to work done by time taken. So, power is basically work done per unit time. Now, we know that work done is equal to the amount of energy consumed. So, power can also be defined as the rate at which energy is being consumed. So, we can redefine power as energy consumed by time taken. So, P is equal to E by T. And one more thing we have to remember, that as work done is a scalar quantity, power is also a scalar quantity. It does not have any direction, only power has magnitude. Now, what are the different units of power? As we know that power is equal to energy consumed by time taken, or P is equal to E by T, and we also know that SI unit of energy is joule and SI unit of time is second. So, SI unit of power is watt, or it can be written as simply capital W. So, watt is equal to, if we replace the SI units in the given equation, P is equal to E by T, we are getting watt is equal to joule by second. So, when we are expressing this mathematical relationship in a sentence, we are getting the definition of watt. That is, 1 watt is the power of an appliance which does work at the rate of 1 joule per second. As watt is a small unit of power, sometimes bigger units of power called kilowatt and megawatt are also used. As you know that kilo means 10 to the power 3. So, 1 kilowatt is equal to 10 to the power 3 watt or 1000 watt. Similarly, megawatt is 10 to the power 6 watt. Another common unit of power is called horsepower or HP, which is equal to 746 watt. 1 horsepower is equal to 746 watt. Now, let us do some numerical problems based on power. First question is, a body does 20 joules of work in 5 seconds. What is its power? Work done W is given in joules, 20 joules, and time T is 5 seconds. As we know, power is equal to work done by time. So, power is equal to 20 by 5, that is 4 watt. Question number 2. What is the power of a pump which takes 10 seconds to lift 100 kg of water to a water tank situated at a height of 20 meter? Here, acceleration due to gravity small g value is given as 10 meter per second square. Now, mass is given 100 kg and g is equal to 10 meter per second square. Height h is equal to 20 meter, time t is equal to 10 seconds. Now, work done for lifting water will be is equal to mgh. that is 100 into 10 into 20, that is 20,000 joule. Now power is equal to work done by time. So 20,000 by 10, that will be equal to 2000 watt. If we divide 2000 by 1000, we will be converting it into kilowatt, that is 2 kilowatt. Question number 3. An electric bulb consumes 7.2 kilojoule of electrical energy in 2 minutes. What is the power of the electric bulb? Energy consumed is equal to 7.2 kilojoule, that is 7.2 into 1000 joule, 7200 joule. Time t is equal to 2 minutes, that is 2 into 60 seconds or 120 seconds. Power is equal to work done by time, that is 7200 divided by 120, that is 60 watt. Next question. A trolley is pushed along a road with a force of 400 Newton through a distance of 60 meter in 1 minute. Calculate the power developed. Force F is equal to 400 Newton, displacement S is equal to 60 meter. So work done in pushing the trolley, W is equal to F into S. That is equal to 400 into 60 joule, 24,000 joule. Time t is equal to 1 minute, that is 60 seconds. Power is equal to work done by time. So 24,000 divided by 60 or 400 watt. Next question. A car of weight 20,000 Newton climbs up a hill at a steady speed of 8 meter per second, gaining a height of 120 meter in 100 seconds. We have to calculate the work done by the car and power of engine of the car. So weight of the car, W is equal to mg, that is 20,000 Newton. It is given in the question. Height h is equal to 120 meter and time is given 100 seconds. Now we know that work done in lifting something or raising something to a height, that is equal to mgh, that is work done against gravity. But here mg part is already given, that is work done will be weight into height, that is 20,000 Newton into 120 meter, that is, so when we are multiplying Newton into meter, we are getting joule. So 24,00000 joule is the work done. Now we know that power is equal to work done by time. So we are replacing the values and getting 24,000 watt. We are dividing this by 1000 to convert it into kilowatt, and the final answer we are getting 24 kilowatt. Question number 6. A boy weighing 40 kg carries a box weighing 20 kg to the top of a building 15 meter high in 25 seconds. Calculate the power. G value is given as 10 meter per second square. Now mass of the boy M1 is 40 kg, mass of the box M2 is 20 kg, and total mass M is equal to M1 plus M2, that is 40 plus 20 kg, 60 kg. G is equal to 10 meter per second square, height h is equal to 15 meter, and time t is equal to 25 seconds. So work done in moving up, that is equal to mgh, that is equal to 60 into 10 into 15 or 9,000 joule. Power is equal to work done by time. So 9,000 by 25, we are getting 360 watt. Question number 7. The power output of an engine is 3 kilowatt. How much work does the engine do in 20 seconds? Power P is equal to 3 kilowatt, that is equal to 3000 watt. Time T is equal to 20 seconds. Power is equal to work done by time. So work done is equal to power into time. 3 kilowatt into 20 second, that is 60 kilojoule. Last question. How much electrical energy in joules does 100-watt lamp consume? Part A in 1 second and in 1 minute. Power P is equal to 100 watt, time T is equal to 1 second, energy consumed, power into time, that is 100 into 1 or 100 joule. Time T is equal to 1 minute, that is 60 seconds. Energy consumed is equal to 100 into 60, that is 6000 joule. Critical thinking question on power. Avinash can run at a speed of 8 meter per second against the frictional force of 10 Newton, and Kapil can move at a speed of 3 meter per second against the frictional force of 25 Newton. Who is more powerful and why? This is a question from NCERT exemplar. Now the question is, we know that power is equal to work done by time. We don't know any mathematical relationship for calculation of power which involves speed. But the data provided here is speed of two boys and the force, frictional force against the motion. And we know that work done is calculated by the formula work done and displacement, work done into displacement. But displacement is not provided in the question. Rather, speed of the two boys are given. So how to solve it? We know that power is equal to work done by time, but we also know that work done is equal to force into displacement. So we can replace work by this relationship. Power will be is equal to force into displacement by time, or force into displacement divided by time, which gives us velocity. So power will be is equal to force into velocity. So power of Avinash PA will be FA into VA, that is 10 into 8 or 80 watt. Similarly, power of Kapil is equal to PK is equal to FK into VK, that is equal to 25 into 3 or 75 watt. If we compare the values, we will be getting that Avinash is more powerful than Kapil. Learning outcome of this exercise. At the end of the lesson, the students will be able to understand the relationship between energy and power. They will be able to know the SI unit of power and will also be able to define it. They will have a knowledge about the larger units of power and their relation with SI unit. They will also be able to solve numerical problems on power. I hope all of you understood the portion of this chapter. Thank you, children.